Hey everyone, hit the question number 21, and then there was some issues with my power, so we stopped. And now let's start with question number 22. Okay, so let me take the weird converter. Okay, question number 22. So what does question number 22 say? It says if point A and B are on the y-axis, so this is the y-axis, the x-axis. So point B and A are on the y-axis. Then what is the area of the triangle? It is an equilateral triangle ABC, right? Okay, so for finding triangle, we need base and height, right? Then it says the coordinate of point B are 0 and 5 root 3. So this is our condition 1. Uh, what does it say? So one thing is already given, that it is on y-axis, so that is given here only. It says this is on y-axis, so on that record anyways x is equal to 0 for both a and b, right? In that case this information 0 5 root 3, in that 0 is not actually any additional information, only thing that we get is 5 root 3. So getting 5 root 3 also, can we get base and height? um, I think we are not getting any dimension, let alone base and height, because this is the distance from the x-axis, which is 5 root 3, right? So in that case, we don't know this distance. Unless we know this distance, we will not even get BA. So if we don't even get base, how will we get height? And yeah, even like if we consider this altitude or this altitude, anyone, it is not parallel to this anyways. It's perpendicular to this, but we cannot. So only dimension we'll get with 5 root 3 is this dimension, and this dimension doesn't, A doesn't lie on the origin. That is, yeah, we can say that is not given. It is given that it is lies on y-axis, but in that case, if it is not given, and so we cannot determine even what is BA. So BA could be anything. It could be an infinite triangle like this. Okay, since it is a equilateral triangle, it cannot be infinite triangle, but yeah, it could be somewhere uh, lying somewhere else. But still, we don't know the actual dimension of even one side. In the second condition, what they are given is coordinates of point C. So this was my triangle. This was A, B, and C. They are given coordinates of C, which is 6 and 3 root 3. Okay, so we have now information of this, which is 0 and some value x, and this is 0 and some value y. So basically we can get this, and we have this perpendicular. Okay, so in this case we know the distance of the altitude, right? We know the height for sure, because uh, height is the x-axis measure, which is 6. So this will be perpendicular to this, will be perpendicular to the x-axis, so this is 6. So in this equilateral triangle, this guy is 6. We know this guy is 6. We know this guy is an equilateral triangle, this is 60 degree. We know this is 60 degree. And we know that the altitude in uh, a equilateral triangle bisects the third side, bisect the angle. So this will be 30 degree. So I'll just enlarge that equilateral triangle there. This is 6, and this guy is 60 degrees. This guy is 30 degrees, and this is altitude 90 degrees. And we know 30, 60, 90 triangle is having this kind of arrangement, is one of the ratios 1 root 3 and 2, so the side should be in this ratio. So the uh, sides here would be, this side is actually, this one side should be the larger, the hypotenuse should be 2 uh 2x basically. Let's take 2k, right? If this is 2k, this guy has to be k, and this guy has to be root 3k, right? So in that case, root 3k is equal to 6, and 6 is equal to k is equal to 6 root 3, which is actually the k value, and based on that we get the base. So base is this, and 6 root 3 into height is 6, so we get 36 root 3, which is actually the area of the triangle. So we can get it from this particular uh, area. Area will not change, so there is only one unique value. So we say this is sufficient, and the answer is B. Let's see what is the actual answer there. To find the equilateral triangle area inside the equilateral triangle can be found. This is there, and ratio between the side using 30-60-90 relationship. Alternatively, we can find the area of an equilateral which is the length of a side. Yeah, sorry, there was some background noise, so I muted for a bit, but this is how it is. It says that if you know the formula where h is equal to root 3 by 2a, so in that case you will know the height once you know the side, and you know the area once you know the side. So basically, if you know the side, you know everything. And yeah, I know the formula, but didn't need to apply it. So root 3 by 2a. Okay. First one is sufficient, it says. It does not give any length of the side or height of the equilateral triangle since we don't have the coordinates of A exactly. Since C has x coordinate of x, the height of the equilateral must be 6. And we can determine the side, hence we can hence the area. Okay, fine. Makes sense. Okay. So let's go ahead and solve question number 23. Okay, so visible by the square of, first thing it says that n is divisible by the square of y. Okay, so that is weird because, okay, square of y. So y is not given because here is not nowhere in the equation. Now it says that it is divisible by square of y. So y is some digit. So let me say something like 64. It's divisible by y. Let me take y as 2. So it is divisible by square of y, which is right. Now I have to take another value which is divisible by square of any other number. So let me take 4 fours are 16, which is the square, and again I take something that is divisible by, sorry, yeah, it is divisible by the square of this number. So yeah, so at least now they say that what is the sum of the integers? Sum of the digits should be 10, sum of the digits should be 7. So two values not sufficient. Let's take the second condition. Second condition says that y power 4 is a two-digit positive odd integer. Okay, so this in itself will never be sufficient. Okay, so this is not sufficient straight away. Now you have to basically take both of them. So n by y such that y power 4 is a two-digit positive integer. So y power 4 is a two-digit positive integer, n by y squared.